Hey guys, welcome to today's video where we'll be going over Avogadro's number. Now in chemistry, particles such as atoms, molecules, and even ions are counted by something called a mole. And this mole can be represented by Avogadro's number, which is right here, and that is 6.022 times 10 to the 23rd. This is a very big number, as you guys can see here if you look down below. Very, very, very large number. Now, if we think about Avogadro's number and what a mole represents, again, 1 mole represents 6.022 times 10 to the 23rd. We can say the same if we were to take a dozen of eggs, right? 1 dozen represents 12 eggs. 12 eggs represent 1 dozen. Or if we were to say we have a couple represents 2 people, a couple of tires, a couple of, a couple of mangoes, right? This represents 2. But in chemistry, when we talk about a mole represents 6.022 times 10 to the 23rd units. Again, whether that's molecules, atoms, or ions, correct? So before I get into some of the practice problems, let's think about this. If I say that we have 1 mole of CO2, right? How many CO2 molecules do we have? Well, if I say that we have 1 mole of CO2, this means that we have 6.022 times 10 to the 23rd of CO2 molecules. If we said we had 1 mole of, let's see, hydrogen, we had 1 mole of hydrogen. This means that, again, we have 6.022 times 10 to the 23rd amounts of hydrogen. So now I want to get into some practice problems that you guys will see in some of your coursework. And the first thing I want to go over is kind of the setup of how to do these word problems. Now, what you'll have in step 1 is typically you'll have a given amount, which is given within the word problem. And then you'll have what you need, meaning, let's say you're looking for the amount of molecules, atoms. The need would go on the top, and at the bottom is what you have, correct? And it'll make more sense as we go through these 3 practice problems that we have. Next, you want to plan it out, or in other words, set it up. Then you have conversion factors, and then finally set up the problem, right? So let me go into kind of this first example so we can kind of see what I'm talking about. So the first example says how many molecules are present in 1.75 moles of carbon dioxide, CO2. To the right, we do have dry ice, which is the solid form of CO2. So first, again, let's go back. We want to start with our given. We are given 1.75 moles of carbon dioxide, CO2. So what we'll do is we will write 1.75 moles of CO2. And that's our given. And what we then want to do is times it by what we need. So the question is asking how many molecules. So we want to know how many molecules. That is what we need or what we want. So we know that 1 mole equals 6.02 times 10 to the 23rd, right? So what we can do is we can then write at the top 6.02 times 10 to the 23rd molecules. At the bottom, we'll write what we have. 1 mole of CO2. And now what's going to happen is the given and what we have are going to cancel out because we're trying to look for how many molecules of carbon dioxide we have. So all we would do then is now have 1.75 times 6.02 times 10 23rd molecules. And we will get the number, if I punch it into my calculator, we will get 1.05 times 10 to the 24th molecules of CO2. And that is our answer. So again, we have our given amount that was given in the equation. We're going to then multiply by what we want. And we know that 1 mole of CO2 would be 6.02 times 10 to the 23rd molecules. Then at the bottom, what we have, 1 mole of CO2. These cancel out. And all we're left with is the 1.75 times the 6.02 times 10 to the 23rd. And we have our answer right there. Now, let's get into this next example. For 1.5 moles of C9H8O4, which is also aspirin, how many moles of carbon are present? How many atoms of carbon is that? So this is kind of a two-step equation. So let's start off with our given. What's given? Our given is the 1.50, right? Moles. We need to figure out the what? The moles of carbon. Moles of carbon. So how would we set this up? Remember, we're going to start with the given, which is the 1.50. So we'll write 1.50 moles of C9H8O4, right? Times what we need. We need the moles of carbon, correct? We want to figure out how many moles of carbon are present. How many carbons are in this? We have 9. C9, right? So there's 5 carbon atoms. So what we'll do is times it by 9 moles of carbon. We'll go at the bottom. We're trying to cancel out this moles. So at the bottom, we'll just write 1 mole of C9H8O4, right? And just like the other problem, we can cancel this out, and what do we have left? The 1.50 times 9 moles of carbon, right? Because again, we're trying to look for the moles of carbon. How many moles of carbon are present? And that's the first part of the question. So if we were to multiply this, we will get, what would we get? Calculator time. We would get 13.8 moles of carbon. And that satisfies the first part of the question. Now, the second part of the question is, how many atoms of carbon is that? So let's start this over again. So now, what are we given? We have 13.5 moles of carbon now. That's our given. We just solved that before. That's our given, right? What are we looking for now? Now we're looking for how many atoms of carbon is that? So we're going to times it by Avogadro's number. This time, this will have atoms because that's what we're looking for. So here we have the given, we have the need, and then we're going to divide that by what? 1 mole of carbon. That is the half, right? And we're trying to cancel these out. So these units will always be the same not the 1, just the mole of carbon will be canceled out. So then what we have left is 13.5 times 6.02 times 10 to the 23rd atoms. And then if we multiply that across, we will get 8.13 times 10 to the 24th of carbon atoms. And that is our answer for the second part of that question. And again, you really want to make sure that you guys set up these problems, given, need, have, and that are given. That statement basically cancels out with this one down here. That way the only unit you have left is atoms, and that's what you're looking for, and then you can multiply right across. Okay, let me kind of move some of that so I can clean it up for you guys so you guys can take a look at this. All right, guys, time for our last example here. And again, if you guys haven't already, make sure you guys subscribe, comment, leave a like. It definitely helps support the channel so I can continue trying to push out these videos for you guys to help you guys on these topics. So with this last example, we have how many moles of aspirin? C9H8O4 contains 0.48 moles of oxygen atoms. And again, yes, another aspirin problem. We seem to love these things, right? So how would we set this up? Let's start with our given. The given value we have is 0.480 moles of oxygen atoms. And I may have to move this down just a bit. So I'll just this and move it right down here so we just have more space, right? Okay, so the given is 0.480 moles of oxygen atoms. So what are we looking for? We're looking for how many moles of aspirin. We want to know how many moles of aspirin contain 0.480 moles of oxygen atoms. So the next thing would be what we want or what we need. And what we need are those good old moles. So we want to know, we can put 1 mole of C9H8O4, right? So we have our given. Let me actually put that in another color for you guys too. So we have our given, what we need, and then at the bottom, this would be our cancel course down here. And that would be how many moles of oxygen do we have? We have 4. So we're going to put 4 moles of atoms. And this is our have. And so now again, what would we do here? We're gonna pull out our cancel pen, cancel these bad boys out, and now what we have is, if we multiply it across, 0.480 times 1 mole, we'd have 0.480 moles of C9H8O4. And then we would then divide by 4 because that's what's left over. Remember, we had crossed these out. So all we have is the 4 at the bottom. And if we do our little math real quick, the answer we would get is 0.120 moles of C9H8O4. Boom, and that is your answer. All right, guys, so I hope you guys enjoyed these little examples that I gave, kind of going over using Avogadro's number and talking about moles, right? So I hope you guys enjoy the rest of your day. Go ahead and please leave a like, comment, subscribe, do whatever you have to do. I'll see you guys next video. Peace.